Hello guys, welcome to this video, how to scale to 1 million of user. Let's start real small, like imagine we start the smaller pieces, not knowing certain things to how a large scale enterprise will handle more user. The 1 million is more hypothetical, like we are not really gonna determine 1 million, but it's just more like to give you a sense of how large scale application work. Let's go start. I'm not gonna go through talking too much. Imagine we start with a small application on your computer. Right? You build a React application and it's just right here. Small, make it small. No database, nothing, just a small application in HTML or whatever you're able to see it with your locals. And you decide to deploy in a server in the cloud or whatever so that anybody can actually use it. So I'm gonna mimic the server down here with it. And yes, it's just gonna be a server. We're gonna call it app. Let's call it app. And when we reach out to it, it's deployed to this server. And the app is gonna be called iDev Journey. Obviously, I don't own the domain though, so if you wanna buy it, go for it. And I'm gonna call it the IP 234 234 234. This is gonna be the IP. And if I the link is this. So you have your HTML application with a little bit of style that anybody can access online and it's doing its thing. And people start going through it, generating data, all of that. Until you hit the limits. Because obviously all your data is handled inside of this server. And the server may be having 2 GB of storage or whatever you could tell. And all your data are just inside here. And that's the first limit that we get. And that's where you start thinking of, oh, maybe we're not going to be handle all the user here. Maybe we need a database. That's the goal of the database. Separates this computes from your actual data. So anybody else could be using that because if you have your data here, use it somewhere else, it's just here. You can query anything, maybe just a JSON file. So that's why we go ahead and create the database. And the database is right here, one single database. And what database is solving is just storing your data. But think about it in the real world, like the way you store your books and the way you store your clothes are not the same way. You have a structured way of you have different way of storing things depending on what they are in the real world, and that's the same with data that we use in a system. Based on your data form, based on the way you access it, you may need to use different kind of database. It does exist two main sort of database: SQL and non-SQL. SQL is the more popular one, being used for a while. And NoSQL, we have different other type of NoSQL, specific for certain reason. Documenter DB, Vector DB, and all of that. We can go deep dive into it, but a database is a whole topic by itself. So this is the first thing that we solve. Everybody that go to your websites is able to access your websites to this IP, and you no longer store your data here. You store it to your database. Life is good until there's more people accessing your data, your websites, and they start getting timeouts because those 2 GB of storage could not handle all of them. That's why we introduce a new topic into your system. What if instead of storing coming all into your one machine, we can add many other machine so that all the computes that we manage here could be across all of them. So that's what we're gonna do here. And instead of one machine, we're gonna have two machine. We can add three or four, but I'm gonna start with two. And at the beginning, you were being able to access it directly to this IP. But now there's two IP. There's one here and one here. Imagine that we have two, four, and maybe two, three, five. There's two machine now. And that's why there's a concept that's come. I say we're gonna introduce what we call a load balancer. A load balancer, as the name says, it balances the loads. Simple definition, right? I'm gonna call the load balancer. So the load balancer will have its own IP address. I'm just making up IP address right now. All right. So instead of going straight to 234, 234, 234, now our application will just access the load balancer. Go for the load balancer and let's put some space here. And the load balancer will choose at which server is gonna send the request, either to server 1 or server B. Call this one here, the IP address of here, the IP address of here, and they're still both 2 GB. It doesn't matter at this point, but you get the points. All right, now your application start getting some of superpower. So you start getting a little bit grades. And we have your application where instead of your domain name, you access it, the load balancer balance the load between the two server. And now more user can use it. And the more user using your application, obviously it's not heavy on your server, but it start getting heavy on your DB, right? Because more user need to write and read data. That's now your part, the power of your bottleneck here. And to solve it, we'll introduce, I'm going to talk about two way of actually scaling your database. And not just a database, but just two way of scaling things. Server. We call it vertical scaling or horizontal scaling. Scaling. Vertical scaling just means adding uh, a bigger machine. So imagine your server was 10 gigs. Now you're gonna make it 100 gigs. But horizontal scaling is just adding more 10 gigs machine. So the same way that we did here was actually an horizontal scaling, where instead of upgrading the machine so that we actually handle more user, we can uh, add more machine so that the load is gonna be separate. Here, since we choose horizontal scaling, here we're gonna choose vertical scaling. And that's what we're gonna do, where all the data is gonna be where we write our application down here to a bigger machine. Let's actually make it big so we know what we are doing. After we did that and the users start using our application, we start seeing something interesting. Users are reading more data than they actually write. Like they're more looking at the data in our application than are actually producing data. And that gives us an idea of how to improve our database using another technique. We're going to call it read replication. Imagine this, since this one is just a single server that we are using, instead of having it handle all the read and the write is is becoming a little bit too much for that single machine to do it. What if we can separate the reads from the writes? And that's why most of the application do to avoid certain load in their application. And to do that, we're gonna use two database, one that we call the master, and the other one that we call, I'm gonna call it nodes. You can call it slave, whatever, but I'm just gonna call it nodes. So the master DB is gonna be used for the read, and the nodes DB is gonna be used for the write. Oh, what did I do? Actually, it's going to be the opposite sides. We are going to use the master DB for the write and the nodes for the read. And some of database do that underneath, under the hood, that you don't even know that they're doing it. And what will happen is every time that you're gonna write like post, update, or anything like that, it's gonna be sending it to the master DB, and the master DB will update the the nodes so that it could be used for the read. And this will help a lot. Now, if you can upgrade this DB for having more CPU and storage so that it can handle all those reads, all those writes, and you can handle update here depending on whatever you want about the read. Actually, here, since I talk about the fact that there's more read, we make it smaller, and then I make it bigger. I make it bigger, or I'm just adding more machine. But we're not stopping there. We help removing the read and write, and to optimize our application also to handle more user, we can introduce a new concept what we call caching. So in application, the most expensive things that you could do is an operation inside of the DB. And when you reduce an operation about a DB, you actually save into a lot in terms of latency. And to help with that, we can introduce what we call cache. Cache is actually a fast storage or a fast database. So that's another concept again about actually learning. And instead of reading every single time inside of that DB, we will introduce this cache, will which will do one thing. Instead of reading it here, we are going to read now inside of the cache, and we are going to update the cache based on here. So now when the user go to your website, they come down here, which process through the server, and they are able to write down here, and they are able to read their database down here, which will help now more. And we can actually optimize again our system in more ways, because remember, the more user we come down here, one of the bottlenecks become this load balancer, right? There's two ways that we can optimize for here. The first will be the same way that we update by adding a cache. The same way we can add what we call a CDN, content delivery network, where instead of every single time that a user gonna go hit your endpoints, they can have a cache, they can use a CDN, and one of the most popular CDN is Cloudflare, and it's like a, a server that's all over the world, which make it closer to the user. And those are actually server, and you can store some of your data down here, and that avoids to go all the way to your server. So every single time based on your policy, now you can update, especially if your website, the updates take long time. For here, our system, we were reading more. So our data doesn't update too long. So we can have access that here. So which means 50, 60, 80% of your user can be using your system and just stopping by the CDN because all the data are already here. And if they pass this place, they can go all the way down and use the cache. If they still need to go all the way down, they can go all the way down to the nodes, which will help handling more user. And we can actually, I say there's two way we can optimize to this place. Instead of having a single load balancer, you can have multiple load balancers. That's why most company do, and to avoid the single point of failure. So every time you go to reach out to your uh, IP address, you can have two load balancer which will handle the way to balance your loads between those different server. Have it here and have it here. So yes, as you could see, we went from just a single application that's deployed to actually using a load balancer to add more server so we can utilizing and uh, add more like handle more user. And we went further down by actually optimizing our DB, not just using single DB. We can use a master and nodes DB where they're gonna write in one DB and read in another one. This is just an introductory. We will go deep down into many other topic because there's a lot of topic to handle here. How do we update data inside of a CDM? There's a policy that you need to set up. And the load balancer is a whole topic by itself too, because how are you gonna uh, handle the load for each server? Are you just gonna randomly choose which server is gonna go to which one, or are you gonna make it based on your IP or anything else? It's another topic. And the DB also. It's true that we use read replication here, but there's more way that you can optimize your database to handle more user. And that's the fascinating world of system design. We will go deep down on each of one of them. And yeah, if you have a question right now, let me know that I can answer. And yeah, see you until next time.